Welcome to Doc's Garage. Not making this video to get a bunch of likes or to make some money. I'm doing this video specifically to help out people out there that are trying to do the same thing I've done. Put cruise control, real cruise control, on a Harley Sportster. I should say at the beginning, this video is for entertainment purposes only. Yeah. Well, let me explain why I'm putting cruise control on. There, of course, is a throttle lock on the Harley. And you can utilize throttle locks. In fact, you Google cruise control, you'll get a whole bunch of links for throttle locks. But throttle locks are not real cruise control. When you put a throttle lock on, essentially what it does is holds the throttle in the position that it's set in. You go up the hill, you slow down. It locks your throttle, not your speed. You go down the hill, speed's way up. Throttle lock works okay if you're on a straight grade. But I put on a lot of miles, sometimes up to 2,000 miles in a week. 1,000 miles each way to Sturgis, and I don't trailer my Harley. So long stretches of road, anywhere from 350 is a typical day, up to 700 miles a day. So I want real cruise control. Now, Harley doesn't make cruise control for the Sportster, though it seems it would be easy enough to do. They could, and I have no doubt whatsoever that at the factory, they've played with it, they've done it. But apparently there wasn't enough of a demand for it, because they look at the Sportster and think, well, that's a round town and, taking a short tour type of bike. There's a lot of Sportster riders. They go for the long haul because the Sportster, not a cruiser. It has the flyback, the throwback of a real experience on a motorcycle. Well, the difference that we have to deal with when we're dealing with the Harley Sportster is unlike the cruisers. It uses cable and not wire. Now, throttle by wire means like on your Road King or on your Ultra. When you turn the throttle, it doesn't actually connect to your intake, whether it's carburetor or whether it is fuel injection. It doesn't activate your throttle body. Throttle by wire goes to your ECM, your computer. And then the computer actually has a control that it sends to the throttle body to open the throttle body to the proper position. It's computer controlled. Whereas the Sportster is actually what is called throttle by cable. And by cable, it means the throttle, when you twist it, you are actually moving a cable, and that cable goes directly to the throttle body, opening it up or closing it up, and adjusting your speed thereby. You need this. It's an actuator. On the old cruise control systems I used to install on automobiles, you would actually have a vacuum booster unit. But alas, we don't have vacuum on our motorcycles. So you have to have an electronically controlled actuator. The actuator, on the end of it, simply has a cable which will connect to your throttle body, and it will pull it in or pull it out and adjust your speed thereby. Now, Harley does make their own actuator unit, and I've seen people try to adapt that. The challenge that we have is the Harley actuator unit is controlled by the ECM. And because I can't hack the ECM programming, it makes it so I technically can't program that ECM to control it the way it's done on a Road King, for example. So what do? We have to have an actuator unit that is with its own computer, so it can be programmed and it can actuate the throttle without vacuum electronically. There happens to be only a couple of these units that are available on the market. One of them is from MC Cruise, which is an Australian company. Heard good things about them. I contacted them, however, they said they don't have a Harley Sportster to test it on. So although they will sell the unit, and it was over $1,000, they said they didn't have the tech support to offer. Well, $1,000 for a cruise control actuator unit, even though it has very good responses from people that have used it, have installed it, rave reviews. That's a lot of money to put on an aftermarket cruise unit. So I decided to look around. The Harley actuator wouldn't work. The MC Cruise actuator is quite expensive. And I thought of taking something off of another motorcycle. Started looking at, could I strip down a Honda and maybe take their parts and utilize it? Then I ran into this. This unit is from Rostra. Rostra. Now they will tell you straight up that they do not support putting their units onto motorcycles. On their website, they disavow and will not give technical support if you choose to install it on an ATV or on a motorcycle. I would assume that it's just product liability. If you install it, you screw up and make a mistake and get killed, somebody could try to sue Rostra. However, their Rostra unit has been used on numerous motorcycles. In fact, it is this very same Rostra unit which is used on Victory motorcycles. Yep, the Polaris Victory unit, Victory motorcycles made by Polaris Company. They actually use this very same unit, and if you look, you will see this unit is what's used when you go and you Google and look up Rostra Cruise, or excuse me, Victory Cruise Control. So it has the same unit. I figured, hey, if it works on Victory, I can adapt it for my Harley. All right. This same unit is repackaged by several other companies as well. I believe Dakota Cruise also uses a Rostra unit. It happens to be a good unit, but also a very well-priced unit. If you pick up this unit by itself, you will be able to purchase it and at about in the range of $350 plus the switch. Typically the switch anywhere from $50 to $70. So for a little over $400, you can have a Rostra unit. However, here's a good caveat for you. I purchased my unit brand new for $99 plus shipping and tax. It cost me $120. Brand new. Why? Because I purchased a unit, and at the time of this taping, there are several dozen I know that were available. This unit was made for a 2004 Chevy Veo. And so it was slightly customized with extra bracket made for a Veo and connectors that were made for a Veo. But if you're buying this unit just as a bare unit, you're making your own connectors anyways. So why not just buy it, I thought. I purchased it. Let me show you what was included in the package. This is the kit I purchased for a 2004 Chevy Aveo that we will be modifying to work on the Harley Sportster. It includes the electronic actuator. It includes what they call SAC parts, just connectors in order to help in the process. It does include what you would see as a cruise control switch normally mounted on your steering column of a car. It could be mounted, for example, to a turn signal switch. We will be adapting it for use on the Sportster as well. You can purchase another type of switch that is referred to as a dashboard switch. I've seen that utilized before. It also includes a wiring harness. And although we will be using parts of this wiring harness, we'll be having to, of course, adapt it for the Sportster as well. There are two types of connections that we'll be making here in installation. The first is a mechanical installation. That will basically be putting the actuator onto the unit and then connecting this to the throttle body. The second type of connection are the electrical connections. We'll be making connections, of course, to power and to the switch unit, and then to the sensors necessary for the operation of the electronics. I looked at the mounting for the actuator unit several different ways up front, but wasn't satisfied with either heat issues, ventilation issues, or obstruction issues, since the size of the unit mounted could interfere with the fork and with other elements. So I decided that the best place for it would be mounting it on top of the belt guard. When I turn the throttle and adjust here at the throttle body has on the side the movement here. The top cable is the return cable. The cable that wraps around the bottom is the pulling cable. It connects here. In order to hook onto that cable, I need to pull it out here. In order to loosen it down by the throttle body, I have to take the front cable here, just roll back the plastic or the rubber sleeve, and then I need to disengage the cable. In order to make the connection between the throttle body linkage and the actuator cable, I've made a 3-inch braided stainless steel cable. Basically, it is a 30-pound test 9-inch wire leader that is nothing more than a fishing leader. It costs $2 at Walmart to purchase 6 of them. This braided stainless steel cable I shortened to a 3-inch cable and have the leader connection on it for connecting to the end of the Rostra. Trying to give you a good picture of this. The cable comes around underneath, so I take a little tool now that the cable is loosened, and I pull the cable around, and then this cable can be made to come out in theory. There we go. I press on it from the back side, and there the cable is out. The end here with the loop on, I will then loop around this and put it back inside. Okay, throttle cable is back in place. The throttle cables come down to the throttle body. They have a unit that keeps the cable in place while the centerpiece of the cable goes and moves back and forth. I need to do something similar to mount the end of the cable for the Rostra unit. From the Rostra unit, mounted on the belt guard, cable is coming up, running along the right side, and coming down where I have a connection made to be able to pull on the throttle body. In order to make that hold properly, I tried a clamp that I wasn't pleased with. Instead, I am switching to Motion Pro cable clamp for throttle idle cable. It's a 2-piece design. I chose to have the black one. It also comes in a chrome. In order to put on the Motion Pro clamp, I had to remove cable from the top of the throttle body, cable from the side of the throttle body, and to access it and to get it to hold into place, I used a hot glue gun to hold the back of the clamp in place, and then I used 1/8 inch on a 3/8 inch socket set with a 1-inch extension just to turn by hand. I also used a small pliers, long needle nose, in order to hold it while I was putting it in place. Definitely challenging. My choice in mounting the Rostra unit where I did was based upon my saddlebags. I probably will, at this point, since I have everything finalized, move it back a little bit further, and then it could be even hidden behind the saddlebag itself. In this case, I drilled 2 holes and made those holes by removing the front of the belt guard connection, so I was able to pull the guard out and thereby drill, and then the guard moved back without having to disconnect it from the backside. I am using 1/4 inch by 20 by 1/2 inch screws. Those are simple machine screws, and they were put in from the underside, so there is only about 1/8 of an inch between the head of the screw and hanging down below the belt guard, still more than 1 inch away from the belt itself, keeping the belt safe. I also chose to use some thread lock in order to make sure I didn't have a problem of those coming loose. Inside the Rostra control unit are the dip switch settings. Units that ship as a universal cruise have a small rubber door to access the dip switches. Those that ship as a specified model, like for the Aveo, have a cover which does not have the access panel. You have to remove the 4 screws and, yes, void the warranty, which you don't get anyways because you're putting it on a motorcycle. Open up the panel and the switches are accessible. In order to set the gain, switch 1 is on, switch 2 is off. That makes it low gain. The selections are extra low, low, medium, and high. And these affect the surging nature. Then 3, 4, 5, and 6 are the pulses per mile. For the Sportster, 3, 4, and 5 are on. 6 is in the off position. This sets it at 24,000 pulses per mile. The Sportster actually creates 96,000 pulses per mile, but you will have to use a 4-to-1 divider in order to lower the Sportster vehicle speed sensor readings to where the Rostra unit can actually pick it up. We'll cover that next. Then we have the engine setup timer. This is set up for 4, 6, or 8 cylinder vehicles. Obviously, you're only 2 cylinders. The setting that is used for the Sportster is 4-cylinder extra high. So 7, 8, and 9 will be in the on position. Switch number 10 is the vehicle speed sensor wave output. The Sportster uses a square wave signal, so switch number 10 will be in the on position. Switch number 11 is the transmission type. Switch number 11 on the Sportster is in the off position because it is a manual transmission. Switch number 12 is a type of circuit. We are using an open circuit on the Sportster, so switch 12 will go into the off position. Up next, we need to preset your multi-pulse. Otherwise, you'd have to use the Rostra signal divider. Preset it in order to have it dividing the signal by 4. The Sportster puts out approximately 96,000 pulses per mile. And that is too high for the Rostra to read. So we use a signal divider to divide that by 4, lowering it to the 24,000 pulses per mile that the Rostra can read and utilize to be able to lock in your speed.
Now there are two options. You can purchase the Rostra signal divider, which divides by 4. It has only that option, and the part number is listed here. The price is $69.95. The other option is to purchase the multi-pulse unit. Multi-pulse gives you the option of enhancing, dividing by 2, 4, 6, or 8, and choosing what you want it to be as far as your dividing rate. It comes preset in the dividing by 2. It's very simple to change. There's a little clip inside with an excellent set of instructions that you just move into the position of the 4 division, well marked inside on the circuit board. The multi-pulse unit is on eBay for $29.95.
I created a customized wiring harness to go from the front of the Sportster back to where the ECM is under the seat. The wires match the 6 wires that come off of the switch unit, with one additional wire coming out that is for the clutch switch. The wires from the beginning to the clutch switch are 18 inches long, and then the remainder to the 4-foot, which will go under the seat. This was made with silicone rubber tinned copper wire. The purpose of using silicone is it's very high temperature. I don't have to worry about melting underneath the area that gets hot, because you're just above the heads for a portion of this. And also then I'm using heat shrink tubing, 5/16 heat shrink tubing, which I have yet to heat. I take my completed harness and it will go alongside the other wiring harnesses up into the cavity here, where I will make the connections to the switch. In this place I will be connecting my clutch.
Harley Davidson very graciously makes available all of the wiring schematics for you, as well as a lot of other information for you on your Harley Sportster, as well as other models. The website address is serviceinfo.harley-davidson.com. There's no charge to register. It's just a great service from Harley Davidson. Here is the schematic of the left hand controls where your clutch is. You'll notice on the clutch switch there are 2 wires connected, black which goes to ground, and the black with red, the BLK/R, means a black wire with a red stripe. You will follow that wiring harness down to where we are, about 18 inches from the end of the cable. And the easiest place to connect to the clutch switch is here. You connect the wire from the new harness, which we've made, to the clutch's black with red stripe wire from the left side harness. The reason for this is then when you pull the clutch, it disengages the cruise control, one of the safety features. To make this connection, I simply used quick wire splice. I picked these up from Harbor Freight. They're available many other places as well.
Cancellation, and then I will be routing it just like you see the other cabling coming underneath, going around the other side, unclipping here, and coming behind. And if you have, of course, a heat shield here for the second head, I'll be coming around this side of that head. But I also do have high temperature silicone, so I will be safe on that. You got to make sure you use the silicone wiring. And bring it down where I will then feed it up theoretically in the same place I have fed here to make my connections, and then slide them down in. I have now put the two ends, which are designed to go to the switch, at the end of my cable connection from the harness that I ran from the front all the way to the back. Reason for putting these on, technically I could have hardwired the switch, because technically I could have hardwired the switch, just take the switch ends, and let's see, the switch ends I could have just hardwired them in. But if I wanted to change the switch, because this currently has the style switch, which is really designed for a car, but if I wanted to change that style to the type that is the dash mounted, which would look a little perhaps cooler, we'll see what it looks like when we're done, it makes it so that I can change the switch and just plug a different switch in. That's the motivation behind it. I also, once I finished putting the cable ends on here, I took my ohm meter and I tested the resistance from the units here, following it back all the way to where the harness is coming out over by the ECM. Made sure that the cable connections were good. All of them were low resistance, so we're in good shape. To do the 12 volt power, I use this Bussmann fuse tap. It adds a circuit, is what it's called. Looks like this. Looks like a mini ATM fuse that you would just plug in. But then it has a pigtail off of it. And the reason for choosing this is on the Sportster, the lower left hand on the fuse box there is open, and it is called an ignition accessory slot. So you can tap 12 volts off of there, which does not have power unless the ignition is on. This is what the unit looks like when it's plugged in. I have that running up in front of the battery, under the frame, and coming up here under the seat where I'm making the rest of my connections. The electrical can seem a little daunting, but in reality, there are only 10 wires that come out of the Rostra unit. The connections aren't as hard as they seem. I have the wiring running connected with a couple of cable ties next to the throttle unit and running up behind the oil tank through the frame and under the seat. Let me show you under the seat where the connections are made. Here's the completed wiring under the Sportster seat. I'm going to just set things to the side so you'll be able to see the connections that have been made. This is the multi-pulse unit that divides the vehicle speed sensor pulses in order for the Sportster to be down to where the Rostra unit can read it. I'll show you those connections in a bit. This is the cable that comes up from the Rostra unit. These connections are then made, including the connections that go to this second set of wires right here. This is the harness that is going up to the front to the switch. A number of the wires coming out of the Rostra unit here just go directly up to the switch. including what is white here with a green stripe, is actually going up to the clutch. And that is the switch that tells the Rostra unit when the clutch is engaged, shut off the cruise control. The green, the red, the black, the yellow go directly to the front switch. Have then several other connections here. The orange that's coming up from the Rostra unit here is being connected to this unit that came from Rostra, which is a 4 amp fuse link. This goes to, let me gently pull this out for you. The connection that is made on the right front controller, which is your throttle controller. This is where your brake switch is for your front brake. This is the voltage that is coming off of the always-on 12 volts from your brake switch. And that is being connected here. Let me pull it in a little bit closer for you. The orange wire that is running up to the front of the switch unit is used to feed what is referred to as a wheat lamp. All that means is it's the LED light that is on the switch, so that when you turn on the cruise control, there's a little green light that comes on the switch. This is considered an extra accessory, but it's nice to have to tell you that it's actually engaged. This orange wire is connected to this 4 amp inline fuse that is provided by Rostra. This is in turn connected to what is the 12 volt always on connection from the right front brake. This is used as an accessory circuit in order to feed that wheat lamp used off of what is the wiring for that right front brake. Simply taking off of this unit here, try to get this where you can see it best, an orange wire with a white stripe. So you're connecting using that connector here to the orange wire with the white stripe, running to the fusible link of the inline 4 amp fuse, running then to the orange wire to the front. The other connection that is made here, try to get this where you can see it very clearly, also off of the right front controller. This is the negative brake. This means that this is not activated unless you pull the right front brake. So this is what's referred to as a cold or negative side. It's only activated when the brake is activated. This is a red with a yellow stripe coming off of it. This connects to the purple wire or the violet wire that goes back into the Rostra unit. Of the connections of the voltage, I showed you this from below, where we have the 12 volts 10 amp coming up. This goes to multiple locations. One, it goes to the, try to get this where you can see it best. I have a connection of the blue, and that is going up to the front switch as well. And from there, I also have it connected to the red which is going to the multi-pulse unit in order to feed the voltage to this pulse unit so that this can divide the vehicle speed sensor pulses. One other connection that is made is there is a brown wire. So I have three wires. The blue that goes to the switch, the red that goes to the pulse unit, and the brown which feeds back into the primary harness to the Rostra unit. Then there is also a ground connection. On the ground, you'll see that, try to make this as clear as I can. Here I have the bolt here that is connected to the frame. It made a very good connection, and it is essential to have an extremely good quality connection to ground. Otherwise, the Rostra unit will not function properly. I have the black, which comes out of the Rostra unit harness, going to here. And also, I have grounded here the multi-pulse unit. So there are two grounds going there. Now, the TAC connection is not utilized on this because we're using the vehicle speed sensor. So the TAC wire has to be grounded, which is a dark blue wire. And I also have that. Along with the black wire, the dark blue wire is connected to ground. The other connection is the vehicle speed sensor wire. The vehicle speed sensor comes off of the crankcase up through this main harness, and I've connected to it here. It is a black wire with a blue stripe. I had to cut away a part of the outside housing to get to that wire and put a connector on it. That connector, the black with the blue stripe wire, then leads off to the yellow, which is the input, the pulse input into the multi-pulse unit. The pulse unit is fed with the yellow wire, and then the green wire is the pulse output. That pulse output goes to the gray wire, which goes down to the Rostra control unit. This multi-pulse unit is grounded and also has one of the feeds off of the 12 volt running down to our fuse box. Additional note, you'll notice that my connections that I've made are utilizing a heat shrink and soldered connection. I actually soldered the connections first and then put them through with this heat shrink tubing, which has an additional solder link built within it. Here is what it looks like and the source that I used for these. It's not necessary probably to utilize such an extensive connection type, but it's my personal preference. Up next, we deal with the installation of the switch. You saw the switch before it was wired. I'm preparing to put on a bracket. I found that you can disassemble, take the nut off the end, and this is changeable here. I purchased this clamp assembly that's made for heavy-duty light attachments for off-road vehicles. I have the link for you here. I based it upon two things, the size of the handlebars, and in this case, the unit comes with multiple pieces from a simple rubber strip to the sizing to go from 1 1/4 down to 1 down to 7/8 inch for handlebar sizing. I also removed from the back side of the clip a couple of the pieces that are accessories for the switch itself in order to be able to have the switch fit through and be able to bolt on to the backside of the clamping unit. In order to clamp onto the handlebars themselves, I did have to disconnect some of the wire cabling that holds in place the harness that comes from the left control grip. After removing the pieces that actually mount onto it and go into the hole on the handlebars, I did place upon it what you can see here, a couple of plastic ties in order to hold the wiring in place once again. The feed comes around outside of the control unit here in such a way that I cannot slide this completely up. So if you decide to go with a different style of clamp, you do have to bear in mind the wiring harness location. With it sitting this way as well, the switch does give me the ability to reach underneath and press the resume and accelerate button. The location seems to be quite functional, with being able to reach from the left side while the right hand is still pulling the throttle. I can turn it on and set the set or coast, or hit the resume and accelerate if I wish. The wiring for the switch follows the wiring harness from the left controller. It goes underneath the access port here and joins in with the wiring harness that we created previously. By just clipping it on, I'm able to change the switch later should I desire to go with a different type.
With all the mechanical as well as the electrical connections done, let's now go over the testing procedure. Rostra has a built-in diagnostic program. In order to access it, before the ignition is turned on, you hold the on button in and the restore or accelerate button in. Then turn on the key to ignition. Once I let go of the button, the light goes off. Further diagnostic testing assures that the wiring is done correctly. To begin with, I hold the front brake. When I pull the front brake in, the diagnostic light goes on to assure that the brake is working correctly. This is what will shut the Rostra unit off or disengage it when you hit the brakes. A second safety measure is built into the clutch switch. The clutch has to be fully pulled back, and when it is pulled in, you see the diagnostic light shows that the clutch switch will disengage the Rostra unit. Then to test the switch itself, there are two buttons that need to be tested. First is the set coast button on the top of the switch. I push that. The diagnostic light goes on to assure that is wired correctly. The next is the accelerate or restore button on the bottom of the switch. I push that. The diagnostic light goes on to show that it is wired correctly. The Rostra unit will also allow you to test the vehicle speed sensor. But in order to do so, you have to take and move the vehicle a couple of meters forward, a couple of meters backwards. And if done correctly, you will see the red light flash when it receives a pulse from the vehicle speed sensor. That you need almost a second person in order to do, so I find it just simpler. Get on it, take it for a ride, and test out the vehicle speed sensor that way. Out on the open road, you can see I hit the on button, followed up by the set button. Take my hand off, and we are running under cruise control. I'm doing this test at 55 miles per hour on a back road. I have also utilized it, let's say, at faster speeds. Also, I tested it at 45 miles per hour. Less than that is, of course, probably not advisable to use cruise, nor necessary. Let me show you a little bit of a close-up on the speedometer. You can see it's locked in at 56 miles per hour, and it's holding that very steady. Occasionally, when you get a setting where you are close to a half mile per hour readout, like at the 45 mile per hour test I did, it fluctuated between 44 and 45. In summary, looking over the pros and cons of the install, put a lot of work into this. I have over 400 miles on the cruise unit now. A lot of that was done for testing and determining the right setup so that I could have it effective for myself, but also for you. Would I do it again? Well, I would do the install again. Absolutely, yes. I take a lot of trips, and when you're going over 300 miles in a day, it is a really great accessory to have. Would I use Rostra again? The answer to that would be yes. They seem to be well recommended by others. I'm pleased with the unit. The wiring is straightforward. I did have to adapt things, but that's normal when you're trying to do something that's a little outside the box. There was nothing that I could find online about somebody doing this to a Sportster. So that was a little bit challenging. There wasn't documentation out there. It took a lot of work. It took a lot of time. A lot of time was invested into the research onto what would possibly work, to make decisions on the mounting and to design the mounting and the connections for the throttle, the tracing of the wiring and working through all of those settings. Took a lot of time. Now, if I had that knowledge to start with, if somebody had created a video like this and given this information, that would have simplified things. I would estimate that if I had the info that you have now, I could probably do the project in about 6 hours' time, and it would be a relaxed, enjoyable installation. I have many, many, many times more than that invested in it, obviously also to create the video so that you would have this information if you want to play around in this. So some of the pros. Well, first of all, the function of it is good. I would not call it perfect. It is not as good as the custom unit that I have on my truck or on my car, but it's awfully close. Not perfect, and you have some issues like where you put your throttle hand. If you're not wanting to turn that throttle, you can rest your hand on there, but you got to be careful you're not grabbing and twisting. Just let it be and let it relax. It doesn't interfere. I like that. It's somewhat out of the way, and the cost of it was, I feel, very, very reasonable. What about the cons? There are some cons to this project. The first one is the switch that came with the unit. Of course, it's designed for the inside of a car. It's not designed for a motorcycle. So number one, it's probably not waterproof, and I'm going to have to look into how to do some waterproofing on it. The second thing is the LED is designed for inside of a cage, not out in the light. And if you've got either bright sunshine, especially if the light's behind you, you will not see whether the LED light is on or off. Also, if you have sunglasses on or a tinted visor like I have, you won't see whether the light is on or off. So that's a little bit of a problem. I wonder if I could put in a high-intensity LED instead. I might look into that. Pop the circuit board out on it and play around with it a little more. I also think that it would be a good addition, if someone else would consider doing this, to also link it into the back brake for the shutoff. Now your front brake has 90% of your braking. And if you're not using your front brake, you're crazy, because that's your primary brake. And all you have to do is so lightly touch it and the switch goes on. So it's linked into the front, but it might not be a bad idea to also link it into the rear brake as well. Some changes that I would do if I had the opportunity: I would probably see if I could adapt the Harley Davidson switch unit that is built into the cruising models. If I could get one at a reasonable price, I think online the price is somewhere around $250. So I just don't feel like investing that much into it. But if I could get one, say $50, I would probably take it apart and figure out how to wire it in and make it work as well. I think that would just be a really sweet addition to it. Another addition that would be, in my opinion, very helpful, I have the upgraded Harley speedometer, which also has the fuel gauge built into it, and it has built into it as well, there's a cruise activation light. Now this is designed not just for Sportsters, obviously, it's also for Dynas and some other models that can have cruise control included in it. But there's got to be a way to activate that light. And I don't know what it is yet. I'm not sure if it's from the data feed of the ECM that is activated, or if there is some pinouts on it. I can't find any info. I'm going to research it more. If I do find out, I will post it online to include that as well. And I would probably make one other change. I would probably mount it farther back so that it would be behind my saddlebags. I might still be able to move it backwards. At this point, though, not really highly motivated to do that. I will be taking, though, the yellow connector on it. I'll be blacking that out and making it so that's really not visible. It'll probably blend in fairly well, and it's not obtrusive, and it's not in the way of the passenger's foot peg, so it's fine. But that sums it up for you. I hope this video has been helpful, especially if you're contemplating doing something like that. I realize this could be applied to more than just the Sportster, but Sportster is the greatest motorcycle in the world, so probably just upgrade to a Sportster. Thanks for letting me share it with you. I hope it was helpful for you. Whether you put a like on it or whatever, I don't care. Because I didn't do this to get likes. I did it because I wish somebody else had done it, so I would have this info. I hope it's been helpful for you. God bless you. Keep both wheels down. Safe journeys.